Hello, this is Jennifer Martinez, and in this video we're going to look at applications of right triangles using trig functions. The first example we're going to look at is the distance across a lake. So to find the distance RS across the lake, so we have a picture here, we're going to find this distance RS. A surveyor stands at a point T, and he realizes he can easily find this distance. So he measures that off. He lays off length RT to be 53.1 meters. And he then measures that angle T from TR to TS, they call it angle T, to be 32 degrees and 10 minutes. How does he do that? Well, he uses a protractor. So here's a picture of a protractor. You can see that does proportionally look about right. So his protractor would be really small, and he'd put it on top, and you can see it's about 32 and something meters. If you remember, 10 minutes means 10/60th of a degree. So they break that up into some smaller. If you look here and count these, there's about 6. So 10/60th is about 1/6. You can get how many minutes there are. And then angle S, he could stand over here and do the same thing from the point he found on point T, and he found that that was 57 degrees 50 minutes. We're going to use this to find that distance. That also told him that he had a right angle, didn't it? Because if this is 57 degrees 50 minutes, that adds up to 90 degrees. So we now know this is a right angle. So I'm just going to use the 32 degrees though in 10 minutes. And I realize here that we have the opposite and we have the adjacent to that 32 degrees. So I'm going to use tangent. So tangent of 32 degrees 10 minutes is equal to the opposite, and the opposite is the RS over the adjacent, and that's the RT, or the 53.1. And you can see that we can come up with the equation to actually solve for RS. So I'm going to multiply both sides by 53.1. So we came up with the distance across the lake. So I'm going to take 53.1, I'm going to multiply it by tangent of 32 degrees in 10 minutes. We need to do that on our calculator. I always first make sure that my calculator is in degrees by going to mode, right next on the upper left here. And then I just type it in, 53.1 tangent of 32, and this means plus 10 over 60. So that's what I have over here, 10 over 60. Can't see the whole thing at once, but if you press enter, that should give you the answer. And I rounded to the nearest tenth. So that would be a 33.4, since that's a 9, so it's 33.4 meters. And I rounded to the nearest tenth because they gave me here 3 significant digits, 1, 2, 3. So usually whatever is given, that's what I give back. Now on our calculator, you could have put 32 degrees and 10 minutes using the angle function here. So when typing tangent of 32 degrees, you could just do 32 and then go to angle, which is right next to math here, above. So you go second angle and then do a degree, and then 10 minutes. And you put a little minute there for number 2. So you just press 1 and press 2. And you can see you would get the same answer. So let's try our next application. The next application goes over angles of elevation or depression. So the definition of an angle of elevation, it's always from the horizon. So looking at the horizon, you go up for an angle of elevation, and that same horizon, you go down for the angle of depression. So let's use this to find the height of a tower. We're going to draw our own picture here. The shadow of a vertical tower is 40 meters long, and the angle of elevation of the sun is 34.6 degrees. So find the height of the tower. So here is my tower, and it's telling me that the shadow, so I'll draw a shadow here. Here's my shadow, is 40.6 meters long. And it says the angle of elevation of the sun, so I'm going to start here, and the sun is going to come in and hit that and produce a shadow. So this angle of elevation is 34 degrees, 34.6 degrees. And we're looking for this height of the tower. I could call it H, I can call it Y, I can call it X, whatever letter I want. Or we could label the points like they did on the one above. I'll just call it Y, since it's a vertical distance. And again, we have the Y and the X, we can use tangent, right? The opposite we have, and the adjacent. Since we know tangent of theta is the opposite over the adjacent, the opposite is Y, and the adjacent is 40.6. And by the way, we actually do have the angle there. I should have wrote 0.6 degrees there. How do we solve for this? We could just multiply both sides by 40.6. So you get 40.6 tangent of 34.6. And then again, you just put that on your calculator. What did I do here? I multiply both sides by 40.6. So that would be the answer. So plug that in on your calculator. Again, making sure you're in degrees. And this time you just put in 34.6 here because it's already in decimal. And that should be your answer, about 28. And rounding to the nearest tenth is still 28. So I'm just going to say 28 meters. And you can see here, this is 3 significant digits, but this is 3 significant digits because the next one, if you remember, was 0.0. So that's good enough. Last example here is the angle of depression of a light. Now we're doing depression, and this time we're going to find the angle. A company safety committee has recommended that a floodlight be mounted in a parking lot so as to illuminate the employee exit, as shown in the figure. So this time they're giving you the figure. Find the angle of depression of the light to the nearest minute. So this is the angle that you want to find. So here's your floodlight, and they want to mount it so it illuminates the whole parking lot. Okay, so what is that angle? So right here we have, if we have this angle, these are alternate interior angles because these are both horizons there. So I'm going to assume that's the same theta. And now I have a situation where I have the opposite and the adjacent, but I don't have the angle. Again, opposite and adjacent is tangent. So we have tangent of theta. And tangent of theta is the opposite of that, which is the 39.82, over the adjacent, which is 51.54. By the way, you could have used cotangent. You could have done adjacent over opposite, even on the ones above. If you were given the hypotenuse, then you could have used sine or cosine, depending on if you had the adjacent or the opposite. You could also have used the secant or the cosecant. If you could use sine, you can always use cosecant. If you use cosine, you can always use secant. Yep. So how would we solve this? This is where we would use tangent inverse. So what I'm going to do is I'm going to say, because the formula for tangent inverse, if you have y equals tangent of x, this means that tan inverse of the y equals x. for inverse functions, you flip the x and the y. So that's what I'm going to do here. I'm going to take tan inverse of this 39.84, and you can get the decimal first, but you don't have to with our calculators, and that's going to be equal to theta. So that's what I'm going to plug into my calculator. And again, I'm going to make sure I'm in degrees, as long as you have not turned off your calculator or the battery hasn't gone out. It should still be in degrees, but you can always go and check every so often. The mode is in degrees, or if you changed it. We're going to deal with radians in chapter 3, the next chapter. And once you did that, you just, if you notice, there's a tan inverse right above the tan. So that's what you're going to do. To get the tan inverse, you use the second blue key there in the upper left, type in tan inverse, and then you're going to type in 39.84 over 51.74. You cannot see the whole thing, but that's okay. Just in the parentheses and hit enter. There it is, about 37.596 degrees. That's in decimal. But they did ask for the nearest minute, so you could take that 0.5964 and multiply it by 60 to find out what minutes are, or you could just go back to angle. Remember, the second is how you get to angle. The angle here is right next to math, and you're going to choose number 4 for degrees, minutes, seconds. So I'm going to go ahead and press 4, press enter, and there it is, 37 degrees. We just care about how many minutes there are, so that would be about 35 minutes. So there's the answer, 37 degrees and 35 minutes.